Hi, welcome back to a video series on MAT 1033 Intermediate Algebra. My name's Sean Perry. This is video number 14, Graphing Linear Equations. So in this video, we're going to go a little bit deeper into graphing equations, which are lines, and we're going to employ some of the skills that we've learned from the past 3 videos. So if you haven't watched those videos yet, I suggest you go back and do that. But this video will also be somewhat self-contained, so if you want to stick around, feel free. For our first example, we're going to look at several different methods for graphing a line that has a slope of 3/4 and a y-intercept of 2. So before we go on, think about how you might model that equation. What would the equation for a line look like with a slope of 3/4 and a y-intercept of 2? There's a pretty good form of an equation that we could choose if we are given the slope and y-intercept, and that's slope-intercept form, y equals mx plus b. So we identify the slope as 3/4, the y-intercept is the number 2, and we put those down as follows. Y equals 3/4 x, 3/4 times x plus 2. This gives us an output y for any input x that we choose, and we're free to pick whatever x we like. X could be 0, and we'd get 2, the y-intercept. X could be 1, and we would get 3/4 plus 2, 2 3/4. But we're free to choose any x we like, and we only need to pick 2 of them in order to fully graph the line. Specifically, if we want to graph a line, we need 2 points, so we could use a table to produce those 2 points. And we have the freedom to choose whatever x's we like, so let's pick the easiest ones. Here's a little pro tip. If your slope is a fraction and you choose multiples of the denominator, it'll cancel, and you'll just get a nice whole number that you can plot. So this is a slick way of avoiding fractions, even if you have fractional slope. So in other words, let's pick 0, which kills this term and gives us 2. So when x is 0, y is 2. And pick 4 to match this denominator. That cancels with the 4 and gives me 3 plus 2, which is 5. So our 2 points that we want to plot are 0, 2 and 4, 5. I've plotted those down here. You'll notice when I make graphs, I generally only put the tick marks that I need. And here is the point 0, 2. Here is the point 4, 5. And we connect them with a line. Now, that's one way to do things, is with a table. And in general, even if it wasn't a line, even if it was just some equation and we might not know how to do anything but evaluate it, we could still plot a variety of points this way. So if you ever get stuck, a good way to graph something is to use a table. But we have something very specific that we're graphing here. We're graphing a line. So another good way that we could graph this thing, especially if it's already in slope-intercept form, we've been given the slope and the y-intercept, is to start at the y-intercept and then follow the instructions that the slope gives us to get to the next point. Let me show you what I mean. So here I have identified the y-intercept. It's a great starting point, 0, 2, easy to get. And the slope tells us the inclination of the line, or the steepness of the line. It tells us how far we should go over to the right. That's the bottom number, even if it's a 1. And it tells us how much we should go up or down. It's positive, so we're going to go up by 3. So we start here at 0, 2, and we go to the right by 4. 2, 3, 4. And we go up by 3. 1, 2, 3. And it brings us to this point here. This point is, of course, the 4, 5 that we found by using the table. But we can get it also this way using slope in this sort of like instructional sense, where slope tells us how to march along and get the next point. So this is another good way to graph this line. Now, this is not true for things which aren't lines, but it is true for things which are. When you're graphing lines, you only need 2 points. For every 2 distinct points, there's one and only one line that goes through those 2 points. In other words, we say that 2 points determine a line, because they tell us, well, 2 distinct points, right? Mathematicians like to clarify, I don't mean 2 of the same points. Right, duh. But, it's still worth mentioning. We mean 2 separate points. And if you take 2 separate points, they're connected by only one line in flat space. More on that later. So now what about if we're given some other information about the line, or we're given other forms of the line, other equations that represent the line, like standard form or point slope form? Then usually what we could do, I think, is the most simple way of doing this, is to just put it in slope-intercept form, right? Now that we know how to graph things in slope-intercept form, just solve for y, use your algebra skills to solve for y, rearrange things, and then graph using the method above. So let's do an example. So here's one that's in, well, not quite standard form, right? Because this is a negative term, but it's in some kind of form here. And it is a line, right? There's just an x and a y. They're not really multiplying each other. They're just hanging out. This is going to be a line. Let's see how we can see that. First of all, let's try to solve for y. So we add x to both sides, right? That gets rid of this negative x over here and moves it from left to right. Then you just get 3y is equal to x plus 12. We don't combine these two terms. I don't know what x is, so I don't know how to add it to 12. I have 3y on the left-hand side. To get rid of 3 times y, I divide by 3. We divide by 3 on both sides. Remember, you have to divide everything on this side, both terms in the sum, because really we are distributing 1/3 into both of them. And we get y equals 1/3 x plus 4. 3 goes into 12 4 times. So let's see where these numbers all appear in graphing this line over on this side. I would start with the y-intercept, 0, 4. So we go to the 0 marker for x, that's right in the middle here, aka the y-axis, and we march up to 4. Here is our first point. Then the slope, 1/3, tells us where to go from there. It says you're going 3 to the right and 1 up, which brings us to 3, 4. So we plot that point, and then we connect those 2 points with a line. We're done. That is how you graph this equation. Now, it's worth talking about horizontal and vertical lines as special cases, even though kind of technically they do fall into the category that I mentioned above. You can use the same kind of way to solve for a variable and do that, except, well, not really for vertical lines, right? Because you can't solve for y, there are no y's. So maybe we should just talk about those two special cases because they are, maybe distractingly simple, right? They don't look like the other equations do, and so we should think about them separately. So remember your equations for horizontal and vertical lines. Horizontal lines look like y equals a constant. So c would be a number in this case. It would still be the variable y, and it would be y equals some number. That's a horizontal line. A vertical line looks like, well, x equals some number. So let's say we had y equals 3 and x equals -2. Let's graph those on the same plane. So here I've done it. I think you can jump straight to it if you say y equals 3. In this case, it does have a y-intercept. This is technically in slope-intercept form. It just has a slope of 0 and a y-intercept of 3. So this really says 0x plus 3 here. You could imagine, quote unquote, substituting x's in there. But wait, how do I substitute x's? There are no x's. Right. So they don't matter, right? Substituting in means not doing anything. And you get a value for y, though, 3. If x is 0, y is 3. If x is 1, y is 3. If x is whatever. So you still just get 3's all the way down for every single value of x. That's why it's a horizontal line. In the same way, if I have x is equal to -2, this is describing a vertical line because x is fixed to and y is free. Y can be whatever you like. There is a point where x is -2 and y is 0. He's right here. There's a point where x is -2 and y is 1. He's right here. Whatever y, there's going to be a point where x is -2 and y is that. And x is equal to -2 traces out this vertical line, this vertical locus. A locus just means sort of like a rule in G. And the rule here is, hey, your x values, they got to be -2. Now, I want you to take a look at the intersection of these two lines for just a moment. The line y equals 3 and the line x equals -2. Where do they hit each other? Where are they true? Where is it simultaneously true that y is equal to 3 and x is equal to 2? It's right here. It's right here at -2, 3. So this point, x is -2, y is 3, the coordinate pair -2, 3, right? That is the inner of the lines x is 2 and y equals 3. Precisely because it is the only place where both those statements, x equals -2 and y equals 3, are true at the same time. Right here is where that happens. So let's just keep that in the back of your mind for later, because soon enough we're going to be talking about the intersections of lines, and this is a nice simplest case of how to interpret what an intersection means. It's where both equations are both true at the same point. All right, now let's talk about some other features of graphs. We'll talk about x and y intercepts. So, hey, speaking of it, the x-axis with our line, or where we hit the y-axis with our line. If the line either of those two things, then that would be their x and y intercept. And yeah, we talked just a little bit just a second ago about horizontal and vertical lines and about y-intercepts. Let's tie those two concepts intercept, right? The x version of this b from y equals mx plus b. So the y-axis is the line x equals 0, right? It's a vertical line, so it looks like x is 0. It's right in the middle of the x-axis. So the y-axis is the line x equals 0. Correspondingly, the x-axis is the line y equals 0. It's right in the middle of the y-axis. It's at the y equals 0 height, and it's all of the x values that it is true that y equals 0, which is all of these guys here. It's this horizontal line, y equals 0. So here I've just marked a generic point on that line. Every point on the y-axis looks like, every point on the x-axis looks like something, comma, 0. The y value is 0, and the x value could be anything. Both 0, right there at the origin. That is where both of them have the value 0. Both x and y have the value 0 at the origin. Now I want you to a generic line. Let's say the line y equals minus 2x plus 6, to be specific. Horizontal, not vertical, nothing special. So here I have graphed it. And let's consider how to find these points. The x, this one's the x. So the y-intercept, exactly where it hits the line x equals 0, the y-axis. So it will be the point where both y is true for some value of x and y, and x equals 0 is true. Well, if they're both true, I can substitute in 0 for x into this equation. Notice the mixture of colors here. Meditate on that. Right? I have this second fact, x is 0. That's all these things in blue. And I have this red fact, y equals minus 2x plus 6. That's all these points in red. Where are they both? Right here at the purple point. So how do we find that point? Well, you plug in 0 for x. If x is equal to 0, I can replace this x with this 0, and I get 6, right? Of course we do, right? This is y equals mx plus b form, and we know that b is the y-intercept. Now let's do this for the x-intercept. So the x-intercept has a little bit more work to do. We are asking about where is it both true that y is equal to 0 and y is equal to, for what value of x? And there's only one value of x for where both true. That's going to be where y is equal to minus 2x plus 6 and y equals 0. So what can we do? Well, we can take this fact, y equals 0, we can plug it in for this y, and then we solve for x. So again, inverse operations, you want to get down to this x, you start with the addition subtraction stuff, we get rid of addition by 6 by minusing 6 from both sides. That gives me minus 6 is equal to minus 2x, and then we divide by minus 2 to get rid of this minus 2. Negative 6 divided by negative 2 is positive 3, and this cancels to 1, so we just get x. So we get x is 3, and that's, what's evidenced on this graph over here. Yes, yeah, it hits the x-axis at 3. So think about how we find both of these. We find y-intercept by plugging in x is 0 and evaluating for y, because with y equals mx plus b form, we're already solved for y. And for the x-intercept, we plug in y equals 0, and we're not solved for x yet, so we have to actually do a little work and solve for x. But that gives us a number again, and that number corresponds to this number here, the x-intercept. So now I'd like you to take these down as critical notes. Remember, I want to see these. This is your validation that you've watched this video. The y-intercept is going to be where x is 0, and we find that by plugging in 0 into this equation, and yes, it is just the b in y equals mx plus b. The x-intercept is a little bit different. It's going to be where the line is true and y equals 0 is true, so we set the line equal to 0 instead of y, and then we solve for x. minus the b, divide by m, and that will be the c in your x-intercept. Now, I just want to include one more thing here before we go on. This point, we call it b, but its coordinate is 0b, right? There's the b that you have in this y equals mx plus b, but all points on the coordinate plane are actually two numbers, an x value and a y value. This one is 0b. Likewise, this point here is the coordinate c0. The x value is c, the y value, well, that was 0. Okay, so here's your praxis exercise for the day, your practical application of what you've learned. Let's say I gave you a line with an x-intercept of -2 and a y-intercept of 3. Can you find me the equation for this line in slope-intercept form? Can you graph it, please? Give that a shot, and we'll see how you did. Okay, let's see how you did. So the first thing I would do is I would extract that we have 2 points now. We were given an x-intercept and a y-intercept. That gives us the following points. You could pick either one to go in either order. Remember, that doesn't really matter for calculating the slope. But in this case, we have y2 minus y1 over x2 minus x1. And that gives us this value here. 3/2 is our slope. So now that we know the y-intercept, we could just plug that 3 right on in here. This is our slope. This goes right here. And we have our equation. From there, actually, we don't need anything more other than our 2 points in order to plot this line. We have the x and y intercept, so putting them down and connecting them with a line, we have a graph. We're done. So that actually concludes things for this video. Thank you for your patience. Have a great day, and I will see you in the next video. Good luck with your studies.